now this is guided practice 4. We're in section 2.3 and we're talking about trig limits and squeeze theorem. It should be squeeze theorem, not squeezed theorem, but we'll let that go for now. So this guy goes away. Okay. So remember that when we approach a limit, we're going to try to plug in that infinity. And when you plug it in for sine of 3 times infinity, the limit for sine of infinity just does not exist. So what we're going to do is we're going to start with squeeze theorem. Now I'm going to pull out just the trig function. So just the sine 3x. And that function lives between -1 and 1. Okay, now this number, let me be clear about this. What you're taking the sign of, or the argument, having a number in there does not change the values on the outside whatsoever. However, the number in front of it will. So notice I didn't take that 3 in the front with me when I set up my -1 to 1. Because I'm going to build that next. So the next thing I want to do is get this 3 involved. So I'm going to multiply everything by 3. That's going to make this -3 less than or equal to 3 sine 3x. Less than or equal to 3. Now I've got that whole first term, and now I want to add on the plus 5. So let's add 5 to everything we see. So you're adding 5 to -3, and that's going to be positive 2. In the middle, that's not a like term, so I'm going to add it over here to match my function. And on the end, 3 plus 5 is 8. Then I want this bottom piece, so we're going to divide everything by 2x. So if you were multiplying by 4, here's an example where we could think of it as division. And you're going to divide everything by 2x. X is going to positive infinity, so dividing by a positive value does not change my inequalities. So then we're going to have 2 over 2x less than or equal to 3 sine 3x plus 5 all over 2x less than or equal to 8 over 2x. And I can go ahead and simplify these if I want. I don't really want to rewrite it, so I'm going to simplify it when I write my next step. But now I've got in the middle what I'm taking the limit of. So I'm going to go ahead and take my limits. So I'm going to have the limit as x goes to infinity. And here's where I'm going to go ahead and reduce those 2's. So that's going to become 1 over x. Then I have the limit as x goes to infinity of 3 sine 3x plus 5 all over 2x. And on the right, we have the limit as x goes to infinity. And this time I'm going to reduce that 8 and 2 and make it 4. So that's going to give me 4 over x. When I go to evaluate those limits, I get 1 over infinity. Limit in the middle doesn't change. I'm writing a little big, so I'm squeezing this one in. And 4 over infinity over here. On both sides, those are both 0. Whether you share 1 cookie or 4 cookies with everybody in the world, you still don't get to eat any. So therefore, by squeeze theorem, we get that the limit as x goes to infinity of 3 sine 3x plus 5 all over x is going to be 0. On to number 2. All right, for number 2, again, when you plug in that infinity, you've got that cosine. The limit's going to be does not exist, so we've got to go to squeeze theorem. So I'm going to pull out, again, just that cosine x, not the number in front, and that lives between -1 and 1. So I've taken care of the cosine. Next, I want the -4 out front, so I'm going to take this and multiply everything by -4. Now, when I'm multiplying by a negative, I've got to flip my inequalities. So this is going to become 4. Flip it to greater than or equal to -4 cosine x. Greater than or equal to -4. Okay, if you want to rewrite this, then you can rewrite it, reading it backwards with less than or equal symbols. It doesn't really matter to me. Next, I want this piece, the plus x cubed. So I'm going to add x cubed to everything here. That's going to give me, and I'm going to put the x cubed up front because it's the higher power. In the middle, I'll leave it at the back because that's how it's written up above. And then we get x cubed minus 4. And then lastly, I want this denominator. So let's divide everything or multiply through by 1 over 2x cubed plus 1. And that's going to give me x cubed plus 4 all over 2x cubed plus 1. In the middle, we've got negative 4 cosine x plus x cubed all over 2x cubed plus 1, which is exactly what I was hoping for. I was aiming for. And on the right, it's x cubed minus 4 and 2x cubed plus 1. Now that I have that function in the middle that I want, I can go ahead and take my limits. I know this is the part that you don't like writing out, but do it because it's proper notation. It tells the complete story. It lets me know that you know what's going on. Okay. Now that we've got it all written out, we want to go ahead and evaluate those outer two limits. All right, on the left, you're going to plug in and you're going to get infinity over infinity, and you're going to notice that you have the same power top and bottom. So that means the limit is the ratio of coefficients. So there's a 1 in front there, so this is 1/2. My function stays in the middle. And over here, same kind of thing's going to happen, right? We're only worried about the leading coefficient. They have the same power. So you're looking at the coefficient, which is 1/2. And there, by squeeze theorem, the limit as x goes to infinity of negative 4 cosine x plus x cubed all over 2x cubed plus 1 is 1/2. And lastly, on to number 3. So number 3 is going to look very similar to the one that was in your example from the lecture. When you plug in your infinity and you take the cosine of infinity, you get something that does not exist, so we need squeeze theorem. I'm going to pick out that cosine of 5x and put that between negative 1 and 1. Now the only thing left here is this exponential, so let's multiply by e to the negative x. E to the next negative x is always positive, so I don't have to worry about any kind of flipping symbols. So I'm going to have negative e to the negative x, e to the negative x cosine 5x, and e to the negative x. Then we can go ahead and take our limits because we have what we want in the middle. And we can go ahead and evaluate those outer two limits. So when we take negative e to the negative infinity, and e to the negative infinity, both of these are going to go to 0, right? Because e to the x looks like this. And as we go towards negative infinity, my y value approaches 0. And that tells me by squeeze theorem, the limit as x goes to infinity, e to the minus x cosine 5x is 0.